to be looking at is how to divide polynomials. You already know how to divide polynomials using a process called long division. Well, today I'm going to teach you how to divide polynomials using a process called synthetic division. Now, once you've practiced this process once or twice, maybe sometimes 3 times, many people tend to prefer this process. Since so many people prefer this, I do have to put a contingency on when will this process work for you and when will it not work. So we're going to be looking at synthetic division, and we're only looking at when it works when dividing by a polynomial that has a coefficient of 1 on the x. So let me write that kind of a little bit better. Go ahead and write only works when dividing by something in this form, x minus a, you could say. And then make a note to yourself saying that the coefficient of x has to be 1. This coefficient has to be 1. So if I asked you to divide something that said, hey, take x cubed plus 4x squared plus x and divide it by 2x plus 1, this process you could not use. You would have to use long division. But in example 1, where it says use synthetic division to take this polynomial and divide it by x plus 1, here this coefficient is 1. Coefficient. So we can use synthetic division. Now with that said, let's see how synthetic division works. And there's steps up top we're going to kind of follow through and then just be working through different examples. The first step says reverse the sign of the constant term in the divisor. Big words here. This is actually your divisor. It's what we are taking and dividing into the polynomial. What I always say is take your 0 value. So if I looked at x plus 1, what would be the 0 value there? Negative 1. Say what makes this equal 0? Negative 1. That's another way to say reverse the sign of the constant in the divisor. It's another way to say it because, yeah, if we reverse the sign of positive 1, we get a negative 1. But you'll often hear me say, what's your 0 value? Because it's easier for me to just kind of look at. Now, the next thing you need to do is to write the coefficients of the polynomial you're dividing into in standard form and use 0 as a placeholder for any missing terms. So looking at what we're dividing into, first of all, are we missing any terms? We have an x cubed, an x squared, an x to the first, and an x to the 0. Are we missing any terms? No, so we don't need a placeholder here. But I do need to take the coefficients. So what's the coefficient of x cubed? 1. So I'm going to line up that coefficient. What's the coefficient of the x squared? 4. What's the coefficient of x? 1. And then what's the constant? Negative 6. Okay, leave a space and then go ahead and draw a bar. Leave a space and draw a bar underneath. Now look at step 2. Step 2 says bring down the first coefficient. So the first coefficient was 1. We're just going to bring that straight down. Now we're going to multiply that coefficient by the negative 1, the new divisor. So I'm going to go ahead and write what I'm doing. Multiply here. Multiply. And you put your answer under the next number. So what's negative 1 times 1? Negative 1. And then you add straight down. So I'm going to put a little plus sign off to the side saying, hey, add straight down. What's 4 plus negative 1? 3. And then the process just continues. What's negative 1 times 3? Negative 3. And I add straight down. What's 1 plus negative 3? Negative 2. Then I multiply the negative 1. What's negative 1 times negative 2? 2. And I add straight down. Negative 6 plus 2 would give me negative 4. Now, I didn't yet finish the problem, but I do have very important information in my problem that's going to help me. Take a look at your bell ringer. Look at number 3. And I'm going to line it up right here. Number 3, and I'll put that on the screen here. What do you notice about this problem and number 3? Same exact problem. Look at the numbers we got. 1, 3, -2, -4. Where did those show up in our answer? They're the coefficients. Yeah, fun, right? 1x squared, 3x, -2, and a remainder of -4. The only thing you have to keep in mind is we divided an x cubed by an x. So our first coefficient is going to go with an x squared. Because what's x cubed divided by x? X squared. So we have a 1x squared plus a 3x minus a 2 with a remainder of what? -4. Yeah.
Isn't this like the Ruffini theorem?
The what?
The Ruffini, like the mathematician who discovered this.
Ruffini?
Ruffini, yeah, Abel Ruffini.
He might have. Do you know, Miss Thornton, did Ruffini discover synthetic division?
I am not sure.
I don't know. It's possible. I don't know who made it. I was just like, wow, this is cool.
Wait, do you even know who that is?
No,
I don't. All right.
I don't. But there's a lot of mathematicians that we've gotten formulas.
Yeah, Wikipedia.
Maybe if we have time at the end, I'll look it up. You might be right, Ruben.
Okay.
Mariah?
I still don't get how you got the -1.
The -1, you take the 0 value. So if I look at x plus 1, if I set it equal to 0, and I solve, I see, okay, here's the value that I'm going to work with. I'm looking at that 0 value and dividing it in, essentially.
Why'd you do the x cubed divided by x?
Just to know which variable do I start with. If I had an x to the 4th and I divided it by an x, I know that I would need to start with an x cubed. If we look at these two problems, they're exactly the same as number 3 on your bell ringer. And notice how our first term was an x squared. And you know from long division, that's because if we're dividing an x into an x cubed, you would get an x squared to start with. Lizzie?
If you have an x to the 4th power, are you going to get a remainder?
Sometimes. Sometimes. Okay, let's look at example 2. Example 2. What number am I going to put in the little box? -2. Take the opposite of that constant. If this was a factor, that would be called a 0 value. So take the opposite of the constant, which would be -2. Now, what are we going to line up at the top? Coefficients. So what's the first coefficient of x cubed? 1. Then -2. What would come next? -5 and 6. Before I move on, I have to make sure every single power of x is accounted for, starting from the highest to the lowest. Do I have an x cubed, an x squared, an x to the 1st, and an x to the 0? Yes, that's important. Even if you're missing a constant, an x to the 0, you would have to add in a placeholder of 0 if you're going to use this process to solve in order to get the correct solution. All right, now let's continue. Why don't you try this on your own? If you need help, I'm going to do it up here on the screen, and then we'll check our answers when you're done. Josh,
How did you get 8?
how did I get 8? Well, I took that -2, When I brought down the 1, I multiplied negative 2 times 1 to get negative 2. And then I added this column. So negative 2 plus negative 2 would give me negative 4. And then I multiplied negative 2 times negative 4. And that's how I got that 8. Good question. Anybody else? Questions on this? No other questions? Okay, I'm going to ask you to do a quick vote. Put your heads down on your desk like Heads Up, 7 Up. But we're not going to actually play that. I love that game. But heads down, close your eyes. There's 2 methods we just learned to divide. Long division we learned Wednesday, and synthetic division we learned today. Raise your hand if you prefer long division. Okay, hands down. Raise your hand if you prefer this method, synthetic division. Okay, hands down. All right, heads up. Good, that just helps me. I'm going to take another voting like that on Monday. I just kind of want to see what process we prefer. All right, go ahead and flip it over. All right, example 3. Use synthetic division to divide these 2 polynomials. First of all, what am I going to put in my little box? Negative 4. Now, what am I going to line up as my coefficients? This is tricky. Caitlin?
1, 0, negative 13, and 12.
Excellent. Look how Caitlin caught that. What term were we missing that made her say 0? Yeah, we were missing that x squared. So we have to add in that 0x squared, just like if we were using long division. And remember, I ended with that problem at the end of class on block day. And I said you always have to put in a placeholder. Same thing with synthetic division. So let's go ahead and let's plug in those coefficients, exactly what she said. 1, 0, negative 13, and 12. Why don't you turn to your partner and tell them what you're looking forward to this weekend and try this one together. What
No, that's just the thing I'm doing this week. I'm looking forward to it. Sleep in. Yeah, and then
Alright, if you haven't done the problem, quickly do the problem. If you haven't done the problem, do the problem. Alright, go ahead, bring it back up to the front. Check your work with your partner. You should have had x squared minus 4x plus 3. Now, I have a question for you. The remainder is 0. So, is x plus 4 a factor of this polynomial? Yes. In other words, we could say x plus 4 times this, x squared minus 4x plus 3, would equal this original function. it would equal x cubed minus 13x plus 12. So here's my last question. Would negative 4 be a 0 value then?
Yeah.
Yes, negative 4 would be a 0. So if you were asked to factor this function, this would be an easy way to factor it and then find the zeros. X equals negative 4 would be a 0 value. Now that's just kind of taking synthetic division to the next level, thinking about what this means, but that's something that may help us in the next few examples. Okay, looking down at the next concept that uses synthetic division, it's called the remainder theorem. The remainder theorem states that if you use synthetic division on a polynomial, whatever your remainder is will be your answer to that function. So let me say that according to what you did on your bell ringer. What number 4 says is if I take the number 1 and I divide it into the function using synthetic division, my remainder will be 8. My remainder will be the answer to the function. So it's a nice theorem, and it also tells us if we have a 0 value. Because if we have a 0 value, the function will be equal to 0. So let's go ahead and let's see how it works. The only difference in using synthetic division to evaluate a function in order to find the remainder is we don't have to take the opposite of the 0 value. Because this is a potential 0 value, so we can go ahead and plop that into the little box. There's no opposites that we have to take. Then we line up our coefficients. So we're going to line up, well first of all, are we missing anything that I need a placeholder for here? Yeah, what am I missing? Yeah, I'm missing that x to the first, so I need to add in a 0x there. Now I line up my coefficients and I have 2, 6, -5, 0, and -60. Draw your little bar. Bring down the first coefficient. Bring down the 2. What's -1 times 2? -2, and we add straight down. What's 6 plus -2? 4. Good. What's -1 times 4? -4. Add straight down. What's -5 plus -4? -9. What's -1 times -9? 9. What's 0 plus 9? 9. What's -1 times 9? -9. -60 plus -9 gives us -69. The last number is always your remainder. According to the remainder theorem, if I plugged in -1 into this function, guess what I would get out as an answer? -69. So that tells me that this function p, which is really big, when I plug in -1, comes out to be -69. Okay, we're going to try one like that again, and then I'm going to ask you to redo number 4 on your bell ringer using the remainder theorem and see if you still get that answer out of 8. Okay, so flip it over. Let's do the next one together. Example 2, what's going to go in my little box? 3. I don't need to take the opposite. So I'm going to take that 3 and just put it in the box. What am I going to line up as my coefficients? 1, -2. Oh, Isabella, I love it. What did you say next? 0. You caught the missing term. She caught the 0x squared was missing. I love it. If she didn't catch that, we would have had the wrong answer. Unless somebody else caught it, which would be nice too. Okay, we have 1, -2, 0, 1, and -9. But I do often forget to do that. That's one of my most common mistakes. I just like to get started with numbers because I love numbers, and then I miss things like, oh, there's a placeholder. Okay, go ahead and do this one. Go ahead and finish it on your own, and then check your answer up with me at the screen. because that was wrong. I'm so glad you checked me early. Thank you, Lizzie.
Yeah, you're welcome.
You always got me. I times them. Is that? Look up here when you're finished. Did you guys get P of 3 is equal to 21? Yes, good. Give me a thumb up, side, or down about how you feel about this so far. Excelente. Beautiful. Okay, then what I would like you to do, number 4, you can either do it on the bottom or at the back. Most likely you'll do it at the bottom. I'd like you to do number 4 using synthetic division. Do number 4 using synthetic division.
What happens if it on the cube?